Hello, my name is Mark Batney. I'm a farm advisor with the UC Cooperative Extension in San Luis Obispo and Santa Barbara counties. And today I'll be giving you a presentation on using satellite NDVI for vineyard diagnostics. So the goals of this meeting, I'd like to introduce the method to you. I think many of you are probably not familiar with accessing satellite NDVI data. I'd like to explain the benefits and limitations of using this data. And my main focus is to give you a number of examples of how this information can help inform on-the-ground vineyard issues and help us solve problems in ways that maybe we didn't realize we could in the past. And I do want to point out this is not intended to be a complete training on how to use one of these websites. If you do need more focused training on how to do that, please let me know and I'd be more than happy to set something up for us. So the satellites that we're working with, the Landsat 7 and 8, and the Sentinel 2A and 2B. So the Landsat satellites, they take 16 days each to cover the entire globe. And because they're staggered in their passes, that means that one of them passes overhead every 8 days. Now, importantly, the pixel size of their measurement is fairly large, 30 meters by 30 meters. That's about 100 feet by 100 feet. So that's quite a sizable pixel and limits some of the detail that we can get from this data. Landsat 7 was launched in 1999 and Landsat 8 was launched in 2013. And Landsat 9 is scheduled to be launched in September this year, and that basically will replace the older Landsat 7. The Sentinel satellites, 2A and 2B, they cover the globe in a bit shorter time, 10 days for each of them to cover the globe. And because they're staggered as well, it means that one of them passes overhead every 5 days. Now, the really nice thing is that they have a much smaller pixel size in their measurement, 10 meter by 10 meters, so about 33 feet by 33 feet. What that means is that for every 1 pixel from the Landsat satellite, we can put 9 pixels from the Sentinel in the same area. That's a tremendous improvement in the detail that we get then from the satellites. These are newer. Sentinel 2A was launched in 2015 and Sentinel 2B was launched in 2017. And the thing to keep in mind that even though now we have access to over 20 years of satellite data using these websites, the further back in time we go retrieving data, the data quality and quantity is lower than it is if you're only going back, say, over the last 2 or 3 years. So yeah, yes, we can get a lot of the older data, but just keep in mind it's not as good of a quality as the more recent data. So here's an example of what the Landsat satellite pixels look like, these larger 30 meter by 30 meter NDVI values here. And if you're not familiar with how the data from the satellite looks, now when we use these websites, the websites have an aerial image of the region, and we just simply overlay the satellite information on top of that. So that underlying aerial image, that's not being recorded by the satellite. That's a more recent image that just serves to help us locate the fields that we're working in. The satellite data from whatever measurement period we're looking at, in this example, are just those small squares that overlie the measurement area. Now, this was a good example. Interest to me is this center portion where the vines have been dying off. And as you can see, the pixels are fairly large with respect to that area. So if our goal was to only sample pixels which only fall within that affected area, we have a hard time finding those pixels because most of them overlap some of the healthier vineyard or vineyard that's not being affected by this malady. And so we have to be very careful then when we're trying to sample small areas. And oftentimes that's a big limitation when we're using some of the older data. The other issue that you can see is that whenever you have pixels which occupy the edges of the vineyard block and also overlie the road or dry vegetation, you can see they get a much different value than the pixels which are 100% within the vineyard block. So whenever we select and outline the areas that we want to sample with the satellite imagery, we have to keep a substantial buffer between that area and the actual outlined area of the vineyard itself in the map. So here's an example of the sentinel, smaller pixels at that same location, and you can see the dramatic difference that these smaller pixels make now. Far more detail, just visually looking at the pattern here, and that additional resolution really makes it much, much easier to pick out pixels that we could use for our sampling. Also notice the effect on the edges of the vineyard block here, especially in the upper left there. There are pixels which overlap both the vineyard and the dirt road, and you can see they have sort of an intermediate value, but they're much smaller. So we can be a little bit more flexible as far as how much of a boundary we leave between our measurement area and the actual outside boundary of the vineyard area. And I'll give you an example of how we do that. So the other thing to keep in mind is that these satellites and their NDVI imagery, they can't distinguish between different types of vegetation that are within the sampling area. They simply return one number for that pixel, which represents all of the foliage that is within that area. So if you have a situation like on the upper left, where you have these grapevines and a clean tilled floor with no other vegetation, that number is going to represent nothing but grapevine canopy. Conversely, the situation like on the upper right, where you have still substantial cover crop and a little bit of developing canopy, that NDVI value is going to primarily be influenced by the presence of that cover crop. So it's important to understand a little bit about the conditions you're measuring so that you interpret the data properly. And oftentimes sort of the context of the pattern that you see with the data will make it very clear what it is. Both of those upper pictures were taken on the same day. So we have very different conditions in different fields at the same point in time. The picture in the lower left, that's obviously later in the season with the fully developed canopy. We can have this happening in late spring and summer, where we have these weeds growing underneath the canopy. Well, if the weeds are not visible to the satellite, they're not going to influence the NDVI value. If we had a bunch of weeds in the row middle, then yes, that would be more of a factor. So the picture in the lower right, where we have a lot of weed growth and clearly is going to be visible to the satellite, that will result in a much higher number than we would have if those weeds were not present. So again, that's just, we have to understand any vegetation is going to affect the number that we are recording from that satellite image. So where do we get this data? Well, the primary tool that I would recommend that you use is a website called Irisat. This website has both Landsat and the Sentinel-2 data. And the really neat thing is that this website was designed to be used by farmers. It's an extremely practical website. It allows you to create an account, and then you can store all of the information. For example, the fields that you are following, the fields that you have outlined, and it's all retained within the system in your account. So it really makes it really easy to track and follow fields over time. So I highly recommend that that's the first one that you use. Another resource, the Climate Engine, another free website, and I should mention that first website that's free to use. The Climate Engine, that only allows you to access the Landsat satellite data. You can get a whole bunch of other measurements from these Landsat satellites, so this website would allow you to do that. I don't know whether or not that would be of interest. I find this website to be more difficult to use, and the very annoying thing is that you don't have an account with it, so any information you set up, it's not retained. So for example, if you outline one field, get a measurement, and then move on to outline another field, your first field disappears. So it's to me of limited value for the types of uses that I think a lot of us would want to do. And I will mention the Google Earth Engine. This is a newer thing, kind of a newer direction that Google is going, trying to put together a lot of data, satellite and other data together in one single source. Currently, this is only available for non-commercial use, and you have to do quite a bit of programming to get the data. So not something that I think any of us would really want to be using right now for the most likely, but keep your eyes open in the future. Something like this could have an interface which is far more practical and would allow us to get a lot more data very easily from it. So the IRISAT website, this was developed in Australia by John Hornbuckle and others on this effort in collaboration with groups like Google and NASA and the USGS and others. So it's a big effort from a lot of people to make this happen. As the name suggests, I think, it was intended as an irrigation management tool, but that does not stop it from being a great NDVI tool for us to use for a variety of things other than irrigation. Now, one caveat that it takes the NDVI value from the satellites and converts that number to a KC, an irrigation crop coefficient. And this is then the value that it reports to us. Now, numerically, the KC and NDVI are almost the same, so it's not a very big change. And that chart on the lower left there shows you that relationship, that linear relationship. It may be easier to see on the right there, those colored bars. So to go from NDVI to KC, it's just a very small multiplier to make that change. So I'm going to start with a number of case studies here to show us how we can use this data here to really, I think, inform a lot of things on the ground that may not have been clear to us before, and that this satellite NDVI information really illuminates, I think, in a really neat way. And this first example here, this is a table grape vineyard in the San Joaquin Valley. And what you see here in the springtime, a number of the grapevines were showing very poor growth. They were just at bud break. It was either very delayed, and then once the buds did start to move a little bit, they just wouldn't grow. So this is something that we see in vineyards. It's not unique to this site. This happens all the time. And often when a farm advisor is invited out here to look at it, we kind of hem and haw. We think, well, maybe this might be something due to cold temperatures, or maybe it's dry soils, or maybe lack of some nutrient or too much of something else, but we never really know oftentimes what might be the cause of this. So we often assign it some name, and we call it a malady or a fever, or we think the vine is just somehow in a bad mood and therefore it just doesn't grow. So this is, I think, a really good example then of maybe NDVI can give us a better picture of what is happening. So here's the IRISAT website, and this is the field in question from that picture in the last slide. So what I've done here, I've outlined in red the area that I would like to sample for the NDVI. And what you can see in the upper left, there's a date in that little box, April 23rd, April 30th. So that date corresponds to whatever will show up on the screen as far as satellite imagery. So if I click on the NDVI tab, then this just shows me the NDVI values from that time period here. So here, this is an interesting example. Even though this is very recent data, and as I mentioned, this website uses the Sentinel data, and in my experience, it preferentially displays the Sentinel data when it falls within this time frame. In this example, we're looking at Landsat pixels, and we know that because they're so large. So why would this happen? Well, the satellites, they have a big limitation, and that is clouds. So if during this period, April 23rd, April 30th, if when the Sentinel satellite passed over, if there was cloud cover, then there's no data for that pass. So therefore, the system reverts to the Landsat data if it's available. So that is then what is displayed here. If you look to the left, you see there's some blank areas there that don't have any pixels assigned to them. Well, that would be the result of cloud cover. So in this case, we were lucky. The cover was good within our target area, but had we chosen the field to the left, we would have had some data gaps because of that. Now, if I click on the KC square there instead of the NDVI, what the system does it calculates then, based on the NDVI, it calculates the KC value for my selected area. And if you can look at the scale on the upper right, you can see that this sort of brown to yellow color is a fairly low value, which corresponds then to this time of the year and these vines just beginning their growth cycle. So now to get more information, if we click on that square, the system brings up these two charts automatically, okay? And initially the time frame on these charts is from the day that we've accessed this website, that would be the date on the right, back 12 months. So we're looking at the most recent 12 months of data in this chart. And it displays two charts. The upper chart shows the percent field visibility to the satellites and also the crop coefficient. The lower chart shows water balance information, shows daily ETC in the small blue circles, and then the green shaded area is referring to the cumulative ETC over the entire 12-month period. So we can change the dates on this chart setting by going into the small settings icon there to the right of that series of icons that are within that small window. If we click on that settings icon, it opens up this window, and where we put planting date, if we now change this date to the first day of the 12-month period that we're interested in looking at, and then click apply, that will then update these charts to show whatever 12-month period that we want. So for me, for this example, I would like to look at the calendar year. So I've entered in January 1st, 2020. And now the time frame has shifted. So we're looking from January 1st, 2020 until December 31st, 2020. Now I know these are kind of small, so let me zoom in a little bit here. And I should mention, I'm only interested now in this KC value, which is basically the NDVI. That lower chart that shows the water use, that method that they're using to calculate that is just multiplying the crop coefficient that's been estimated from the NDVI by the reference evapotranspiration for the time period. So it's a very simple measurement. The problem for us is that measurement does not include a deficit factor. So, or in other words, it's assuming that the crop is using water at the 100% of potential capacity. And for crops like wine grapes or almonds in California, we know that that's not how we irrigate them. So we have limited direct use of that irrigation data, but that's a topic for a whole nother discussion. I want to focus on the NDVI data here, like in this upper chart. So what can we see here? If we look over here on the right-hand portion of this axis here, where we get January, February, and March, we see the values are fairly low, around 0.2 for the crop coefficient. There were probably some weeds out there, maybe a little bit of cover crop, something, but not a whole lot of vegetation. Now here, right in about early beginning of April, starts to grow. The canopy starts, the grapevine canopy starts to grow quite quickly. You can see it increasing the value of the KC. We get up to about 0.9, it looks like. So that's a fairly large canopy last year. And what's interesting here, September, let's say mid-August, the value starts to decline here. So that's interesting to me, how the foliage was not maintained very late in the season. So for example, if they cut off irrigation, this is what the pattern that we would expect to see. The foliage quantity diminishes here. Now here's something I mentioned here, this right-hand axis is the field visibility. And when we have full visibility, it's this shaded tan color like here. And when there's poor visibility or zero visibility because of cloud cover, the value is 0 and there's no data point for that time period. But this data point here, it corresponds to a time when there was a little bit of visibility in the field, say about 15% of the field was visible to the satellite, and it did return a number, but we can see that this is not a good value. the nice thing about this website, it has a feature to let you edit these occasional erroneous values that do appear. And it's just this little edit button right here. You click that, and that allows you then to correct this number right here. And that's a really neat feature to be able to do that. Okay, but now my interest is, this is an interesting pattern, having this decline here in the foliage fairly early in the late season, we'll say. Let's look at the previous year. So we go back in to this little icon here where we change the date. Now we'll put the planting date as January 1st, 2019 to go back a calendar year. So here's the 2019 season. And we see a very similar pattern. 2019 was a wetter year, so there's a bit more foliage early on here. Then it looks like they did some tillage or got rid of that cover crop and weeds. And then we get strong canopy growth. And what's of interest to me here, you can see that that foliage was retained for a longer time in the late summer and early fall. So that's interesting. Let's go back one more year. Let's look at the 2018 season. Similar pattern, similar amount of canopy growth, and even here, the foliage is retained longer. Okay, so now one more thing we can do. Sometimes just looking at these charts like I am right here will help inform us enough, and we don't have to do anything beyond that. But if we want to crunch some data in a little different way, there's a data tab right here. So right now the graph tab is highlighted, but if we click the data tab, what that does is brings up the raw data that has gone into the charts that we just see right there. And if we click on this download CSV, that downloads a file that then we can open up with Excel and process the data that way. So we can download 12 months at a time by using this method. So if you're going back 20 years, that's you have to download 20 files. But that's certainly one way to get an awful lot of data here in a very straightforward manner. So I did that for these 3 years that we've been looking at, and now plotted that on the same time axis in Excel, so that now we can compare more directly the 3 seasons. And now the pattern becomes really obvious. So in 2018, here's the KC value here stays quite high. It isn't until into October when the KC value starts to go down. So that means the NDVI number is diminishing and we're losing foliage during that time. So how did they achieve that? By continuing irrigation later into the season. 2019, you can see the canopy diminished sooner. So they must have shortened the season by cutting off irrigation sooner. And in 2020, even more so. So that's a very substantial change over time. So this, to me, is the key thing that is happening in this field, that this change in the post-harvest irrigation is probably impacting the vine's ability to produce those storage carbohydrates that it needs going into the winter to ensure that the following spring growth has enough fuel. So with this trend here of diminishing time devoted to that production of those storage carbohydrates, what we would expect here eventually, like we're seeing here in the 2021 season with this red line, is that now that's impacting the growth of the vines. So to me, this is a really good example of how the satellite data over the past several years can really help inform what we're seeing right now. And if we had gone out to the field and saw nothing but this data point right here where the cursor is, just that current point in time, looking at weak vines, without knowing this history, we would really be in a very big disadvantage trying to explain all of that. So this to me is a really good example of how this satellite data can help inform what we are seeing now in fields. So I think that's hopefully we can make similar use in a variety of ways. So let's look at case study number 2. This was another example where also there was some weak vine growth seen in this large field, particularly on the edges of the field. Not really sure what could be causing this. You could think that maybe there's some soil issues, irrigation related issues, maybe this is a disease problem. It's hard to know right now, but let's look at some patterns from the NDVI. So again, we bring up the same chart over the 2020 calendar year now. And the pattern here is interesting. So we see here in the spring, the rapid increase in the canopy, grapevine canopy, reaches a maximum about 0.8 here. And this, I should point out, this is a wine grape vineyard in the San Joaquin Valley. And then after it reaches this peak value, it diminishes very quickly here to a much lower value, something about 0.55. That's a big change in a short period of time. Is then maintained at about that level and then drops off again rather abruptly here around harvest time. So what looks to me like is happening here is that they grew a large canopy, probably did a significant amount of hedging to drop it down to this much smaller size, and then at harvest here, that mechanical harvest probably damaged the canopy enough that now we have this pattern here of lower numbers throughout the rest of the year. Well, if we go and do the same type of looking at a number of years in the past to see is there a trend that indicates a change in management or a change in growth habit, I don't see that. It looks to be quite consistent from 2015 up until 2020. The pattern overall is fairly similar from year to year. What is interesting to me, though, is that there's this pattern of generating larger canopies here in the spring, which then gradually diminish in size as the season progresses. So that, to me, that diminishing canopy size over time throughout the summer suggests that there could be some issues with just water stress. You know, the vines not getting enough water and shedding leaves due to that stress. So let's take a look at data in another way. As I mentioned now with this Sentinel saddle and the small pixel size, we can really start looking at maps to just explain things. And the nice thing with the satellite data, because we essentially have a map created every 8 days, that's a very high frequency measurement, and we can really spot trends as they occur throughout the growing season here. So let's look here. This is the period May 16 to 30th. I'm sorry, 16 to 23rd of 2020. And here you can see that the value of the crop coefficient within this field here is all rather uniform, fairly large value. Now I will point out that this streak right here, this is a ditch, and that there's also a road here, this little narrow one here. So I just included them within the image here. And if we're just doing a visual analysis, that's not a bad thing to do at all. We know what they are. We see the trend here over time. As we proceed here, we start getting some areas of a little bit weaker growth here towards this side of the southern edge of the field here. Let's look a little later. Now in June, some very interesting patterns start to appear. So these areas here, these long straight areas here and over here to the right, that to me, this is because these align with the row direction, I would tend to think this is more of a management effect. For example, maybe this area, maybe it's an irrigation set and it didn't get as many hours of irrigation as the rest of the field did, or didn't get the same nutrients, or it was hedged differently. It suggests to me that this is not a natural pattern here, but rather something relating to the farming that is going on. So that is interesting to me. We are getting more and more weakening here on these edges as well, but yet we're retaining higher levels of foliage down the center here. As we progress further, that pattern is developing more and more. More of the weakness really is happening here on these boundaries on the edge of the field here, while the center is retaining more vegetation. Now, from what I understand of the field layout, this center here is where the irrigation risers run and the drip lines run then from the middle of the field to both boundaries. So the north and the south from the center here. So this pattern may also suggest then that there could be difficulties in delivering the irrigation water to the ends of the rows. So it's certainly an interesting pattern that seems to relate to a number of things related to irrigation here. So based on this sequence here, if I was to try and to diagnose what could be the cause of this lack of uniformity, the very first thing that I would want to evaluate is the irrigation system itself. For a large field like this, it's certainly conceivable that there could be things going on that are resulting in a poor irrigation distribution uniformity. So that would be, I think, one of the first things to look at. You could also look at some differences in soils that might explain why there are certain areas here, like in the southern part, where we see more of a certainly more drought-prone soil, or could potentially be existing there. So a number of things that we could look at. But the nice thing is that this data like this really helps us identify both where and when things could be starting to appear. So we have an idea, and the good thing is if actions are taken to correct whatever is going on, that we then have a way to compare to the past and see how much of a change is occurring. So that's really a powerful tool in a variety of ways. So case study number 3, now we're on the Central Coast wine grapes here. This was just an interesting example where some 8th leaf vines showed some pale foliage in 2020, which typically pale foliage, we think low nitrogen. In this example, I actually used a different website, this climate engine that I mentioned, the one that I don't really recommend you use because it's just not practical for a lot of our purposes. But just to show you, you can get data from it in a fairly similar manner. You go and outline the area that you want to measure, and here you can see how I'm leaving a fairly sizable buffer between my selected area and the edge of the block. And then I just select the Landsat 8 satellite, NDVI. If there is a good thing about this website, you can download multiple years of data all at once. So that is one advantage that it does have. Then once I get the data from this website, I can make a chart like this. So here what we're looking at is from the period May 1st through October 31st of the actual NDVI, because this website just reports straight NDVI. So we're looking at the pattern over year to year. So the vines were planted in 2013, so I don't have any data from 2013. But 2014, you can see throughout the season, the numbers were quite low for the NDVI, as you would expect. 2015, they're larger, 2016 increasing. So that pattern of increasing each year is clearly evident here. 2019, that was a wet spring. So this peak that you see up here in June, May, looks like May to June, that could have been something due more to weed growth and cover crop growth. But what's interesting here is very clear. The 2020 season had substantially less canopy growth than did the 2018 and 2019 during the peak of the growth season here, let's say from July through September. So that, to me, this is what we would expect. If vines were lacking nitrogen, we would expect them to grow less foliage, and that would then appear as this lower NDVI value. So this would be a great way to use a tool like this in some ways to help diagnose ahead of time, and sort of giving you advance notice when things might be problematic. So now with this data, if the grower decides to fertilize a bit more heavily this year, now we have a great index value to be able to compare to. So if the goal is, for example, is to match back to the 2018 and 2019 levels of canopy growth, we have a great target to see, can we reach that? So again, a really neat example of how this tool can help inform things, even when you may not be aware that this is happening. So case study number 4 here, another coastal wine grape example here. Here, now we're going to look at the rapid impact of trunk diseases in a vineyard block that's trained with unilateral cordons. And as you probably know, the long cordons that are used on this unilateral vine are very susceptible to losing lots of foliage very quickly when you get these infections that happen near the trunk. Why is that? Because that single infection near the trunk can potentially wipe out the entire length of that cordon. So this type of training system, you have to be very, very careful to be up on the maintenance here of the trunk diseases. And so here I'm going back to the IRISAT program. And in this example, I'm going to go all the way back to the year 2000. So that's the first year that we have data on this website. So here's the value then coming from that. I've plotted this a bit differently. So each black circle here, each black dot represents the average KC value for June through August each year. So a single dot represents the canopy size for a given year. Now, I suspect from this pattern, since this is the 2000 on the far left, I suspect the vines were planted in 1999 in this block. That would kind of match this pattern pretty well. So you can see the gradual increase in size of the canopy over time. You can see this was the drought here in around the year, let's see, 2012 and 13. That was when the drought was fairly severe. So that definitely impacted the vegetative growth of those vines. But what's super interesting here is the quick decline that happened here. So, it just looks like there wasn't enough effort made to try to maintain these vines against the onset of the trunk diseases. So there may be more to the story here, but to me, it's an example of how quickly the productive capacity of these vines can be diminished when these trunk diseases really kick in. Especially in sort of a very high risk situation, like with these long unilateral cordons here. This is certainly a cautionary tale when you look at the number of years of productive growth that these grapevines produced here at this site. It's quite limited, and then to suffer this very quick end here is certainly unfortunate. So there's a lesson here for us about the importance of managing for our trunk diseases. So along that line, case study number 5, this is a bit more of a success story of a successful renovation of a vineyard. So this was another older vineyard that by the year 2015, the farmer had noticed that there were a number of dead spurs starting to appear. And so he got on this fairly early. He did not let the symptoms become so severe that the vine health was being impacted. So he got in early during the winter of 2015, 2016, cut the vines down to the trunks like you see here, about 1.5 feet high, and then just grew out new vines in the 2016 year. So no harvest in 2016, just focused on growing the grapevines. So here, each one of these dots again represents the average KC value from June, July, and August. So a single value for each year. And you can see the trend, how the values were diminishing, and then the renovation happened in 2016. And since then, just a gradual increase over time. This is, to me, has been a very successful example of what we can do when we're trying to deal with the trunk diseases, provided that we get in and do the renovation before the disease becomes so severe. Case study number 6, another coastal wine grape example. And this is we're looking at the progression of Pierce's disease in a small vineyard block here. Same display here. Look, each dot represents the average KC value from June, July, and August. Here we're looking for the year 2001, 2005, and then 2010 onward. So you can see the values were fairly constant. Even though these vines are quite small, I was surprised how old they are. They're in an area that makes very limited growth, so the vines stay quite small. But the other surprise was how quickly they lost foliage once the Pierce's disease really kicked in. And there's probably 2 reasons for this. One is that as vines were being impacted by Pierce's disease over time and dying off, that adjacent vines were probably trained over to sort of fill the gap with their foliage. So canes just were laid over, which because of the short distance between trunks, that worked out pretty well here. So there was probably an effect of masking the impact of the PD for quite some time on the NDVI values. The other issue is that it's a very small block that I'm sampling from. Let me show you here. So this outlined area in red, this is the area that I was taking that data from. So again, it's one of the challenges here of trying to select the area that you're sampling here, what I did in this IRISAT website, I clicked on the NDVI option here just to show where the layout of these pixels were back in 2015. And by selecting the 2015 date here in this window on the upper left, that made everything that's in the image 2015 at that date. So now these pixels represent that time period. So it allowed me then to make sure that I set my sampling area to overlap pixels the way I wanted, the pixels that represent the field itself. So imagine if I didn't do that, and if I had extended my sampling area over here to the left, that I would have been influenced then quite a bit by this row of trees that's over here. So that would have changed the data values quite a bit. And likewise, if I had gone too far to the right and included some of the dirt road or this riparian area or these trees that are down to the south here, that again would have changed the value. So this sort of points, if we're working with very small areas, we need to spend some time to make sure that we select our sampling area very carefully, especially if we're going back in time when we're working with the Landsat data. So case study number 7, now we're looking at plastic on table grapes. The challenge, well, plastic presents both an opportunity and a challenge. So the satellite looks at this situation and thinks this is clouds and reports it as such. That can be, if our goal is to know how much foliage is on these grapevines, well, that's not helping us at all. But we can use the data in other ways. So let me show you what this looks like here. So here's our chart. So here in the spring, they had cover crops growing in this table grape vineyard. Cover crops were removed, and now we're tracking the growth of the grapevines here, reach a fairly large canopy, looks like about 0.9 kc value. Then here, where it just drops off. So this is where the plastic was put out. And you can see on this percent field visibility, when it's all white like this, then that means that there's no visibility. So the satellites think that this is all cloud cover during this period. There's a few moments here where we get some partial values here. I'm not sure if that's when portions of the field may not have had the plastic on yet. It's a little unclear. We can do some more analysis, actually, like the spatial map analysis, and figure that out. But to me, the neat thing is that we can, from this data, figure when the plastic was put out and when the plastic was removed, because now we see here when the plastic was removed. So let's say, for example, we suspected that the use of plastic like this over time would lead to a reduction in the ability of the vines to store or create storage carbohydrates for going into the winter. If that was our hypothesis, here we have a way to actually test that, because we can see when the plastic is put out and for how long. And then over a number of years, we can track the vegetative growth in the spring and or summer, just like I did in the very first example. So it really could be a tool that we could use if there were some indications that maybe this type of use of plastic or certain types of plastic might be problematic over time. So again, just points to the many different things that we can use this data for, which is really pretty neat. So now my final case study here, all these examples I've shown you are outlining fields, single fields, and looking at data for just that field. Well, you're not limited to doing that. You can make your outlined area as large as you want. So here we're looking at a good portion of the Napa Valley earlier this year. It's kind of centers roughly around Rutherford here. So this kaleidoscope of colors represents the different management that was going on with respect to cover crops this spring. So this is now a great way to compare what people are doing in different years, say 2019 being a wetter year and 2021 being a drier year. So let me show you here what that might look like. So here, the two charts on the left are from 2019. So we're looking at March 30th to April 6th in the upper chart, and April 23rd to April 30th. So just about 3 weeks apart in the data here, 2 or 3 weeks apart. And you can see the change that happened between essentially the first week of April and the last week of April, a lot of cover crop was removed. That's why we've gone from the green and the blue colors in the upper image to much more browns and yellows in the lower image. So that makes sense. We know that a lot of people at this time are going to be removing cover crops out of concern for frost and other things. The 2021 season, looking at the same time periods, you can see there's substantially less cover crop present, especially here in the last month of April. So a great visual indicator of how much management has changed in response to the different amounts of rainfall between the different years. Now, a tool like this now really opens up some neat opportunities. So let's say we had the hypothesis that in a dry year like 2021, that a vineyard which did allow cover crops to grow late in the spring was going to suffer from reduced growth of the grapevine canopy. Well, now we have a tool that would allow us to assess both of those things. We can find the sites and determine how late the cover crops were allowed to grow. And we have the tool in the growing season to track how much canopy developed and compare to prior years. So there's a lot of things that we can do with this data that really would have been much more difficult to do in the past, otherwise a lot more tedious to get the numbers that we might find useful. And I just one last thing here. I hope that watching and looking at some of this these examples has inspired you to use this IRRISAT website and maybe to download some of this raw data that you want to play around with in Excel, because then you can really put together some neat charts. One caveat, if you do go to this data tab, download the CSV, what you're going to find, the date of the values here is in this, what I would call the European format, where it's day, month, and year. The Excel that we have here in the US does not recognize this as a date. So what you have to do to convert this into something that our Excel program will read, in Excel, when you open up that file, you go to the data heading, and then there's a text to columns feature or button. You click on that. It brings up this text to columns wizard. First you had to select all the data before you do this. Then you hit the text to columns wizard, hit next and next a couple of times, and then you get down to this option here. You click date and put DMY for day, month, year. After you hit finish, then that converts that into a format that Excel can work with, and then you can make your charts. So thank you very much for your attention. If you have any follow-ups, feel free to send me an email. If you are using this method and you would like to have some advice on how to do things, or if you have some unique challenges that you would like some input on maybe how it works, please let me know. Well, thank you very much and take care.